Hi there guys. So in the previous video I showed a couple of Sloan piston valves, a navel and a star. Those are piston style valves. And here I've got a Sloan Royal. This happens to be a vintage one, probably from the 60s, that I found. It was new old stock, never used. And this type of flushometer is called a diaphragm flushometer, and it works in much the same way as a piston valve, but the parts are different arrangement. In many ways it's a lot simpler, and you'll see far more of these than you will piston valves. And it's a very good design. It's very simple and easy to maintain, easy to rebuild. These things are so easy to fix. So I've got some parts in the back, as you can see, and I have a few different valves here. I have one here that's disassembled. I'm going to start with this. You can see I've got the handle on this one, and if you can see in there, well, I'm going to show you the handle. You can see that when I move this handle, this rod is going to extend like that. I'm going to put that back in. This is the diaphragm assembly. This is an older one. This section here is called the guide. It's made of brass. Newer valves have a plastic guide. Looks more like this. It might be black on some of them. And in here you've got a device that is called a relief valve, and it sits inside of this component, which is called a molded rubber disc. That's what Sloan calls it in their parts diagrams. And I'm just going to take this apart, because they do come apart. You've got a few different components here. You've got your guide, got the relief valve, the molded rubber disc, and the diaphragm itself. And if you see that thing on the diaphragm, there is a very, very tiny hole, pinhole, orifice in this diaphragm that's called the bypass hole. And so that plays a big part in how this valve functions. Now here you might notice this is a flow ring. This the plastic diaphragm has a form of it right here. That's removable as well. I take the relief valve out and I unscrew the diaphragm assembly. Now this is a little different here. Molded disc, the diaphragm. Now in this plastic assembly, you're going to have this thing. This is called a silencing ring. It has ridges around it. It goes there. Sometimes if you buy diaphragm kits for certain types of urinals, they will have you turn this upside down or like this way, but you can take this ring off, and that for lower pressure or for a higher flush consumption, you take this ring off and then just put the thing back together. That ring doesn't have to be there for the valve to function. And on the older brass guides, if it has a ring, there's a very thin brass threaded tube here that unscrews and the ring comes off. You replace the tube and it gives you a little less flow restriction. It'll increase the flush volume, and if you have low water pressure you may need to remove that to get enough water. Now you got a body, valve body. This whole assembly simply just sits down in there. There's an inner cover that goes over top of that, and then the outer cover screws on till it's tight, and it will compress everything together. The rubber diaphragm will seal against the inner cover, it'll seal against the valve body, and it's there shouldn't be any pipe sealants on any of these joints, really. They're not, you shouldn't have to. So the way this valve works is, you can see there's this surface here which really forms a tube that goes all the way down the valve body, unbroken. The supply comes through, in fact, this component here, not the nut, but this tube here is called the tailpiece. Supply water comes in and it fills this area around the valve seat. I'm just going to call it the valve seat. Water pressure is going to fill this area. It's going to push up on the outer portion of the diaphragm. And normally it will want to push the diaphragm up. Like that, it will actually flex this diaphragm up, and water will force its way over this valve seat down through the valve, and it'll flush the valve at high volume. Meanwhile, as water's doing that, it will find this bypass hole, this very small pinhole. So as water comes into this valve and pushes the diaphragm up, and the valve flushes, you're going to have a very small amount of water seeping through that it'll seep through the bypass hole at a controlled rate, and it'll fill the upper chamber, the whole area, the void above this diaphragm. It will push on the diaphragm, it will push on the top of this relief valve, and the relief valve will seal against this rubber molded disc. So what happens is water pressure begins to fill the top chamber, and because the top chamber as a whole has more surface area than the bottom outside, surrounding part of this diaphragm, at some point the water pressure seeping into the top chamber will equal that of the water pressure coming in through the house line. And when that happens, it will push this diaphragm down. It will push it down tight. The rubber will be pushed tight against this valve seat, and the valve closes, and it will close slowly. It'll close slow enough that a toilet will siphon out, a bowl will siphon out, and as it siphons out, this thing is in the last stages of closing, and it will provide a period of refill for a toilet bowl. So it's designed to to close slowly. Now, to start one of these valves flushing, you have to pull the handle, and remember, it causes that rod to extend. Well, when the diaphragm is closed, I'm going to get rid of this. The bottom of the relief valve, it sticks all the way down out of the bottom of the guide assembly. If this is the handle plunger here, when you rock that handle, what it does is it will bump that relief valve. Now watch this relief valve. You can see it move like that. When that happens, it breaks the seal of this relief valve against the rubber disc, and it dumps the water pressure in this upper chamber. This water, remember, the upper chamber is sealed from the lower except for that tiny bypass hole. So when you push the handle, that happens. It dumps the water pressure in the upper chamber, and at that point all of the pressure in the lower part of the valve pushing up on the diaphragm instantly flexes the diaphragm up, and it pushes the rubber off of that valve seat, and it causes the valve to flush. See, it does that. In fact, it'll push this whole thing up until it hits the underside of the top cover, or the inner cover. So it flushes, and then immediately as that happens, the key to timing of this valve, to getting it to flush a certain amount of water, is a combination of the size of this bypass hole and also the restriction of, partially the restriction of the toilet and the restriction of this flow ring here. That's why if you take this flow ring off, it'll cause more back pressure in the upper chamber as the valve flushes, and it'll cause the top chamber to fill at a slower rate. So when the valve's flushing, immediately that bypass hole begins to weep at a slow rate. It fills the top chamber slowly, and it slowly pushes the diaphragm back until it pushes it hard against that valve seat, and that timing, that metering of the water coming through here governs the volume of the flush, whether it be a 4.5 gallon per flush, or 3.5 or 1.6 or whatever. The 1.6 diaphragms, this diaphragm here, for example, is a 3.5. I think, the way I understand, if you take this, and I could be wrong, but I think if you take this ring off, it makes it a 4.5. A 1.6 diaphragm has, well, the whole assembly has a different silencing ring here that restricts the back pressure much more. And another thing you can see different is, it's this. This is an old all metal, brass and monometal relief valve. A little later they had a plastic head, and then much later ones are almost all plastic. The part number for this is A19A, but there's still different versions. This is a black one that's for a urinal, and it also governs the length of the flush. And there are white relief valves. That's a closet relief valve. There's also green ones too. I think those are low consumption, but that's basically the operation of a piston or a diaphragm type valve. And its advantage is that it's basically a diaphragm that flexes, and that's about it. There's no wear, friction, mechanical wear going on like you have in a piston valve. But the disadvantage is that bypass hole, because it's a very small hole that could easily get plugged if there's any particles in the water. If this hole gets plugged and you flush the valve and the valve opens, there's no, you dump the pressure in the upper chamber, the valve opens, it flushes, water can't get back through the diaphragm to replenish the upper chamber and close the valve. So if that happens, this thing will stick open and it will run and run and run at very high volume until somebody shuts the supply stop off, the control stop, this thing. So that is that. A few different things. Now, one thing you may notice, all of the Sloan piston and diaphragm valves have what they call a non-hold open feature. So you'll notice the shaft on this relief valve telescopes. Well, if I'm simulating the handle action here, when you press the handle, it does this. And then at that point, this whole guide moves up when the valve flushes. Ideally, you release the handle, the guide will come back down as the valve closes, and it will come to rest like that. Well, if I flush the handle and the valve flushes and I hold the handle open, what will happen is the valve will go through a normal cycle. The valve will begin to close. This whole assembly will come back down and rest on the valve seat, and it will simply telescope. That telescoping portion of the relief valve will simply come to rest on top of the handle as the valve closes, and it'll be stuck like that, but the valve can still close without anything to impede it. And then it'll, if everything in here is working properly, you should not be able to hold the valve open simply by holding the handle. You could crank the handle multiple times, but that's the only way you could do it. There are some different features that they have improved or changed over the years. The vacuum breakers being one. This is an old, what's called a V100 style vacuum breaker. I don't think they've made these since the 60s. What a vacuum breaker does is it allows water to go straight through, but in the event, if there was ever a vacuuming or siphoning action, suction coming from the water supply, this would allow air to come in and satisfy that vacuum without sucking dirty water from a fixture into the clean, fresh water supply. So this is a very important device. Long time ago, it wasn't necessarily required by code. You may find very old installations where there is no vacuum breaker at all. There's just a simple straight tube coming out of here. But it's pretty much required. It's pretty well standard now. This is an old style. Actually has kind of like a rubber flapper valve in there. And this one's never been used, which is why it still exists, because if it had been used since the 60s, it would have been deteriorated by now. The current vacuum breaker is integrated in with the flush tube. So you'll see the flush tube has slots in it, and you put in a rubber sack. This is the vacuum breaker, and that's the bottom of it. So this is a cone. So if I stick my finger through this, you'll see, maybe, that there is a hole in that rubber, that there are slits in there, and they naturally close back up. But only if you push through it. So this sack, or the cone, goes in the sack. That's what they actually call it, I believe. This goes in the tube, and what happens is when water flows from the valve through this tube, it has to inflate that rubber sack first before water can force through. And as it does so, it pushes the rubber, it'll seal against all these slots, and this won't leak. But if there was ever suction coming through here, it would suck and shrivel up that rubber and open air into the bottom of this tube, so there's no way it could suck water from a fixture. So that is the V500 style vacuum breaker, and that's what you'll see. Pretty much any flushometer now has something very similar to that, whether it's a Sloan or a Zern or a Delaney or anything else. They make a retrofit kit for the old V100s if you have one, which this one has. Basically you knock out the old core with that old flapper valve in it, and you put in a brass tube that replaces it, that has slots, just like in the V500, and then it takes the rubber sack and it'll take modern replacement parts from there on. The handles have changed a little bit over the years. The really old ones have a stuffing box. There's a hex nut there. Well, there's a gasket under it, a leather or a rubber gasket. You tighten this with a wrench, compresses that gasket against the shaft, and makes this watertight so water can't leak from the valve and come out the handle. The modern version of that, gotta find one. Has a plastic piece here with a rubber boot. That rubber boot is replaceable. It pulls right off and you can put a new one on. You can also interchange the whole assembly if you wanted. These devices are otherwise very similar and interchangeable. And if you had an old stuffing box, you could take it off and put a newer style one in its place. You want to be very careful not to cross thread that. The control stops have also changed over the years. This happens to be a straight one, but the old ones had like a metal screw drive in it with a flat rubber washer. The new ones, they also had a what's called a ground joint tailpiece. That's basically a metal to metal ground joint union connection there. The new tailpieces or they seal with an O-ring. You tighten that nut to secure the connection so the water pressure doesn't force this apart, and you can adjust the dimension from the center of the valve to the center of the supply a little bit, which you couldn't do with the ground joint tailpiece. The new valves also have, you probably can't see that, but they have like a molded rubber cork in them that's actually spring loaded, so it acts as a back check, a check valve. So that's another anti-siphon protection as well. And I think I've covered just about everything I want to cover. Oh, old valves have a metal inner cover, new ones are plastic. And I think that's about it. I think this video is long enough. Thanks for watching. I'll see you in the next video.